Alright, in this video I'm going to be simplifying expressions that involve radicals, and not just square roots but cube roots and other things, and variables and numbers and big ugly numbers and stuff. Okay, so look at number 13. Because the roots are the same, I can put these under one roof. I can basically multiply these together. The roots have to be the same to be able to do this. But so 49 times 7. Help me out. What's 49 times 7, people? 343. Okay, so I've got 343. Now x squared times x to the 4th power, I'm going to add those exponents and get x to the 6th power. Now if I'm lucky, both of these are perfect cubes. So let's see, the cube root of 343. So I'm going to use my table here and see if 343 is on it. Yes, so the cube root of 343 is 7. Okay, so that's going to come out. And I know that variable-wise, x to the 6th power is a perfect cube because it is divisible by 3. So I'm going to get 7. But for the variable, I divide. 6 divided by 3. So that's going to be x squared. So the answer to number 13 should be 7x squared. Any questions on number 13? All right, on number 14, we're not going to be quite that lucky. Let's see, is 1,458 a perfect cube? Well, if it is, it's off the chart, but I don't think it is. Okay, so what we need to do is we're going to have to break this one down into more manageable pieces. So looking at that 1,458, I need to find which one of these numbers will divide evenly into it. Okay, I'm going to start with 512 and work my way down from there. Okay, so I'm going to go like this. 1,458. And I'm going to try to divide that by 512. See if it goes in evenly. Nope, 512 doesn't go. Alright, so 1,458 divided by. Okay, the next thing on my list is 343, so I'll try that. That doesn't work either. Okay, what's next on that list? 216. Whoops, I keep clicking the wrong thing. That doesn't work either. All right.
Did you not try 729?
729. Nah, I shouldn't skip 729. Yeah, 729. I shouldn't have skipped it. All right, 729 is the perfect cube. Okay, so because it is the perfect cube, I can split this up as 729, and we just saw that it went in twice. Okay, it went in twice. So 729 times 2 is the same thing as 1,458. Now, I'm writing the 729 in pink because that is a perfect cube. It's right here. I can take the cube root of it and get 9. So everything that can be simplified, I'm going to write in pink so it stands out. Now, g to the 5th power. 5 is not divisible by 3, so I cannot leave it alone. I need to take this and split it up as well. So I can split up g to the 5th power into g to the 3rd power with how many extra g's left over? 2. Okay, I'm putting the g to the third power in pink because I'm going to divide. 3 divided by 3. This is ready to go now. What do you think I'm going to do with the h to the fourth power? Any ideas? I'm going to split it up as h to the third and h, I hear you saying. H to the third and h, that's the same thing as h to the fourth power. So everything here in pink can be simplified and brought outside. So that's what I'm going to do. The cube root of 729. Okay, I mean you could use a calculator for this, but the cube root of 729 is 9. So that's going to be 9. Now for the variables, I'm just going to divide. Like 3 divided by 3 is 1, so that's just going to be g. And this is just going to be h. So that's it for the pink part. Everything here in blue is just going to stay where it is. So I've got the cube root of 2g squared h. So 2g squared h. So this will be the answer for number 14. All right. Any questions on number 14? Save this. All right, look at number 15. Now, remember, say if I have x to the 24th power divided by x to the, let's say, 8th power. Is this going to give me x to the third power? Is that going to be the answer to this question? No. Okay? I'm not going to divide 24 by 8 and get 3. That's not what you do. What am I supposed to do instead?
Cancel out.
Right, we're supposed to be canceling or subtracting. Either way you want to look at it, okay? What's 24 minus 8?
16.
16. Okay, so this would be x to the 16th power. So remember, when you're dealing with variables, instead of dividing, you wind up subtracting these powers. So that's what I'm going to need to, okay, I thought I was erasing. Hold on. That's what I'm going to need to do on this problem. But first, we need to change this root into a fractional power. So do you understand that the cube root of x is the same thing as x to the 1/3 power? All right, so I've got x to the 1/3 power over x squared. So even though it's a fraction, that's okay. I can subtract. This would be 1/3 minus 2. And I could do that by hand, but you can also use your calculator to help you. 1/3 minus 2. So that gives me negative 5/3. Now, we've learned that a negative power doesn't mean anything is actually negative. It just means you need to drop it down to the denominator of your fraction and make 1 over x to the 5/3 power. All right? Now, in the original problem, we had radicals, not fractional power. So in the end, we have to convert this back to radicals again. So power over root. This would be the same thing as the cube root of x to the 5th power. Now, it doesn't matter whether you put the 5 under the radical or outside the radical. It's the same. But this would be your answer for number 15. Any questions on number 15? That one was a little complicated. Okay. Number 16. I'm curious if the calculator will do this, so I'm going to try. So this is 27. What is it, 512? Okay, to the 1/3 power, so to the oh, calculator did it. All right, 3/8. Brilliant. But here's why we didn't actually need a calculator for that. Remember that 1/3 power is the same thing as the cube root. So all that we're really doing is taking the cube root of each one of these things, the cube root of 27 and the cube root of 512. If you have your table, the cube root of 27, that's 3. That's why we have a 3 up here. The cube root of 512 is 8. That's why we have 8 down here. That's what your calculator did. Any questions on number 16? So, number 17. So this is the one you guys were asking me about? Did you try putting it in your calculator?
We did.
You did? And it gave you a
10 years ago.
10-digit number, didn't even fit on your calculator? That's interesting. Let me do it properly first then, instead of just typing it into my calculator like I normally would. You guys understand, if I had n to the 5th power times n to the 6th power, what's that going to make?
Into 11.
11.
That's going to make n to the 11th power. You understand I'm adding these, okay? All right, what if I had n to the 5th power? What if I had n to the negative 5th power?
That's just A.
Okay, that would just be n, right? Because it'd be like n to the 1 power. So, that's the idea here. All of these bases are the same. So all I'm really doing is I'm adding these exponents, 10, 13, 10, and negative 4. That's all I'm really doing. Okay, so I've got negative 3. 13 and 10 is 23. Minus 4 is 19. Okay, so I've got negative 3 to the 19th power. That's why it was so big. Is this going to be an odd number? I'm sorry.
It's a negative.
Is this going to turn positive or stay negative?
Turn positive. Stay negative.
You had said it right the first time. It's going to stay negative because it's an odd power. It's going to stay negative. So I definitely need to write this without parentheses. So it's going to stay negative. So I've got negative 3 to the 19th power. Now, if 3 to the 19th power is too big to even fit on your calculator, then we'll just have to leave it like this. But you can't leave it with parentheses. You have to show me that you know that that negative is not going anywhere. All right, I'm gonna try putting 3 to the 19th power in my
You have to
calculator.
put a 1 over it.
No.
That's what we got.
That's what you got? Well, that was the answer. All right, your calculator is able to handle that many digits, huh? Huh, how many digits does the calculator do? So yeah, read that number to me,
That we got.
the big number.
116, 226, 1467. BB.
Okay, yeah. If the 19 was negative, it would be 1 over something, all right? But since the power is positive, then we just have this. Okay, you could have left it as negative 3 to the 19th power as well. Anything over 4th power, you have my permission to leave it. Okay, moving on to number 18. Will the calculator do this? Anybody tried it?
Or it gives us one.
It gives you a decimal? Alright, I'm told that this is going to give us a decimal anyway. So I always try putting everything in my calculator when as long as there's no variables. But if I get a decimal, then we have to do it by hand. So let's go for the win. We're going to do the cube root of negative 81. Okay, we're just going to do this separately. And we're going to do the cube root of 125. All right, we need to separately do the cube root of each thing. With the table here, the cube root of 125 is 5. All right, so I know I'm going to just have 5 in the denominator here. Now, I don't think 81 is a perfect cube. Yeah, 81's not on the chart. But 27 goes evenly into 81. All right? Because, let's see, 81 divided by 27 is 3. So I can break this up as 27 times 3. Okay? So that's what I'm going to do. I'll go ahead and do negative 27 times 3. Alright, so the cube root of negative 27, I can do that and bring it out. The cube root of 27 is 3. Right? Cube root of 27 is 3. So I'm just going to have a negative 3 because it's a negative 27. Alright, so I've just taken this out and it became a negative 3. Everything in blue is just going to stay right where it is. So I'm still going to have the cube root of this 3 right here. So I'm going to have the cube root of 3 still there. And this 5 is still going to be there. So this is the final answer. Alright, any questions on number 18? Alright, that's a good place to stop this video. The bell's about to ring anyhow.